What we want to do here is we want to look at the 2ax squared plus bx squared first. Look at this binomial and ask the question, okay, is there anything these share in common? And pretty obvious, right? They share the x squared in common, so we can pull an x squared out. And after we do that, what we'll be left with here is a 2a, right? Because 2ax squared divided by x squared is just 2a plus b. Alright, and now we want to move over to the second binomial over here, and it looks pretty similar. Same kind of expression. Instead of an x squared, we've got a y squared. So they both have a y squared in common. Let's get that out of there. And then what we'll be left with is, again, a 2a, right? Because 2ay squared divided by y squared is 2a, plus b. Because by squared divided by y squared is just b. Alright. Now we can see this expression shares a 2a plus b. So we can factor the 2a plus b out. Let me go ahead and do that. And what we'll be left with is 2a plus b times an x squared, right, minus y squared. But we have to stop at this point and then ask the question, is there anything else I can do to factor either of these binomials? I got 2a plus b, I got x squared minus y squared. Can I factor either of them? Well, the 2a plus b, no, there's nothing that I can do with that. But hopefully by now you're recognizing that this is one of those special patterns, right? Because I've got an x squared and a y squared. Those are perfect squares, right? The square root of x squared is x. The square root of y squared is y. So when I have two perfect squares connected by a minus sign, I just take the square root of both terms and I multiply the conjugates, right? It'll be x plus y times x minus y. Where did I get the x? Well, again, square root of x squared is x. Where did I get the y? Square root of y squared is y. And so I just put them together like this with opposite signs. And then I need to bring the 2a plus b back down. So here's 2a plus b. And now I've factored that one completely. All right, 30. Here we have a polynomial. And we need to do some grouping. Like the grouping was done for us on problem 28. They put these two expressions into two groups with the parentheses. We need to do that for this one. And you always want to be careful when you have these minus signs. So like grouping, this one's not going to be too bad. You just put parentheses around it. When you're grouping and you have this term here that has a minus sign, put the minus sign inside the parentheses, and then I'm going to put a plus sign there just so we know we're not multiplying these two. We're still just adding them. But that's, I think, the way you want to do your grouping. Put this minus sign inside the group. Okay, now it's very similar to 28. Now we look at a cubed plus 2a squared. What do they have in common? Well, what they've got in common is a squared. So we're going to get that out of there. A squared on the outside. And we're going to be left with a plus 2. All right. Here, what do these two terms have in common? Minus 9a minus 18. What they've got in common is the minus 9. Both can be divided by minus 9, so we're going to pull that out. Pull the minus 9 out. And we'll be left with a, right? Because minus 9 divided by minus 9, negative divided by negative is positive. And then negative 18 divided by negative 9 is going to be a positive 2. All right. Well, now these a plus 2's can be factored out. They're common to both, right? So I'm going to pull the a plus 2 out. And we're left with a plus 2 times a squared minus 9. Now, this really is pretty much just like this, x squared minus y squared. Because what I have here are two perfect squares, right? The square root of a squared is just a. The square root of 9 is 3. So now what I do is I just take these terms and I put them in a conjugate pair, right? So I'll just rewrite it. It'll be a plus 2 times a minus 3 times a plus 3. And now we factored problem 30 out completely. There's the right answer for problem 30 right there. Okay, 32 is pretty much the same kind of problem. It's just the numbers are a little bit bigger, but you do the same thing. Like we're going to start by putting them into groups here like this. Again, I'm going to connect them with a addition sign so that I know I'm not multiplying them. And now we just go through the same steps, right? Like 3x cubed, 6x squared. What do they have in common? Well, they both have an x squared in common, but they also both have a 3 in common, right? So the greatest common factor for this binomial is going to be 3x squared. I'm going to pull that on the outside. And then what I'll be left with is x minus 2. Okay. Over here, I can factor out a minus 48 because 48 goes into 96 twice. So I can pull out a minus 48x. No, sorry, just a minus 48. I said minus 48x. And then I'll be left with, again, x minus 2, right? Because, again, negative 48x divided by negative 48 is x. 96 divided by negative 48 is a minus 2. The x minus 2's are now in common. They can be factored out. So I'm going to pull out an x minus 2, and I'm left with 3x squared minus 48. All right. So this is an interesting little expression here. Are there any, like, they're not perfect squares, but is there something that I can factor out of this? And I think there is. I think that 48 can be divided by 3. Am I wrong about that? Let me check it real quick. I'm not sure. Let's do some old school math. So 3 goes into 4 once, right? Subtract them 8. Oh, look at that. Yeah, I was right. I should have known that, teaching math as long as I have, but 16. Okay, so I can factor a 3 out of that. So let me go ahead and do that. So I got x minus 2 times, and let me go ahead, well, I'll put the 3 here for right now. I think we're going to move him over here out in front eventually, but for right now we'll put him right there. X squared minus 16. Okay, well look at this. Now we have perfect squares again. The square root of x squared is x. The square root of 16 is 4. And so now I can just rewrite that in terms of a conjugate pair. Now I'm going to move the 3 out in front. So let me do that just to show like all my steps here. I'm going to move the 3 out front there. Like that. And now I'm going to factor this part completely by using the fact that they're perfect squares connected by minus. You have to be careful. If this was a plus sign, you can't do it. But if it's a minus sign, you can. And so we'll just change that to 3x minus 2 times x plus 4 times x minus 4. And there we go.